getting ready for that. We're all getting ready for summer break. Let's see. Perfect. That's good. Sign in there. Do that. I feel like I'm clicking, approaching my 10,000 clicks already. Okay, so this row is all here. That row is all here. This row is all here. Missing that one, and we're missing true. I don't know where she is. Huh. Okay. So we're going to do a real quick on the board here. I'm going to put something up there just to see kind of like what you're, before we start looking at graphs, what you remember about what we were doing before we ever graphed. So before we started looking at graphs in here of sine and cosine, we were really looking a lot at the unit circle or a circle of any radius r, and we were trying to understand sine, cosine, tangent, cosecant, secant, and cotangent for any angle of rotation. Okay? So we want to do a real quick review of that, see what you guys remember here. So all right. So everyone, of course, knows that that angle there would be what type of angle? What type of angle is that? Tell me everything you can about that particular angle right there. Positive. Anything else? Yeah, which means it's what? Acute. Okay, great. So those two things. Okay, great. Here we go. So can anybody tell me what that is from the picture? Y over R, right? Because I didn't say it was the unit circle. If it was the unit circle, it would just be what? Y, right? Because R would be 1, okay? Cosine of theta, of course, is x over r. Tangent of theta then is y over x. Okay? And then if I came over here and did the other ones, the cosecant of theta, that's r over y. That's the reciprocal of the sine. Secant theta would be the reciprocal of cosine, so it would be r over x, and then the cotangent of theta would be not this, but x over y. Okay? All right, great. So those are things we had to remember. What can you guys tell me about all of, let's talk about these three here. What's true about all three of these for any angle in quadrant 1? They're positive. They're all positive in quadrant 1. Why? Because x and y are positive in quadrant 1, and r is always positive, okay? What about in quadrant 2? Of these three, which one is positive? Sine is. Quadrant 3, tangent is. And then in quadrant 4, the cosine is, right? And if the sine is, what else is? Cosecant. If tangent is, so is cotangent. If cosine is, so is secant. Okay? So, if I look at the sine function here, and I go around the quadrants, it goes what? Positive, positive, negative, negative, right? And then it does what? Repeats, right? It just repeats. And if it repeats, and since it repeats after 2 pi, that's why the period is what? 2 pi. So it starts repeating again. We start repeating our things again, okay? If I talk about the cosine goes positive, negative, negative, positive. And then it does what? That pattern does what? Repeats, right? I mean, look at it, guys. Positive, positive, negative, negative. Slash, then it would do what? Positive, positive, negative, negative. Slash, positive, positive, negative. Do you agree with that? Every time I go around, this pattern repeats. And that happens how often? Every 2 pi radians. That's the period, remember? This would do the same thing. Then it would be plus, minus, minus, plus. Plus, minus, minus, plus, right? That's what's happening there. Let's look at the tangent. The tangent goes what? Positive, negative, positive, negative. Look at it. What do you notice? It repeats. Does it take a full 2 pi to repeat, though? No. Look when it starts repeating. Plus negative, plus negative, plus. So the tangent, guess what? The tangent function, its period is not 2 pi. Guess what it is? Pi radians. It's a little different. It repeats. So right now, one thing we've just learned that's new is the tangent has a period of pi. Sine and cosine are 2 pi. Tangent is pi. Okay? We can see that because the pattern repeats every pi radians. All right? You can see it repeats. Okay. So all of that's kind of important stuff. Okay? Now, let me go ahead and put this up on the board from Desmos. So when we started graphing sine and cosine in here, where there you are. Well, that is not what I want. There it is. So when we were doing this in here, I had this Desmos graph right here, where I could click on my circle, and I could click on this. Oop, I don't want that. Let's just do this. I could go ahead and click on the sine function, and we could see there was a relationship. I don't know if you remember this or not, okay, on here, but we could see that what was true, something's turned off down here, the triangle's turned off. What we saw was, as this was going around, we could see the relationship between the curve, the sine curve, and the circle as we were going around, okay? We could see that it took the 2 pi radians before I got back and started over and would do it again. Then I did the exact same thing with the cosine function. There it is. Why is this thing so wonky? I did the same thing with the cosine function, okay? So here's the cosine function. It's turned off for some reason. There we go. And I could do the exact same thing. Whoop. Right? We go around and we see it's repeating, goes down and gets back up to max, and then if I kept going, it would just repeat the pattern. So the period was 2 pi. All right, notice on here I have the tangent function written as well. Here it is. Okay. So I'm going to turn this on right here, and let me open this. Okay. Now, I want everyone to look at this graph. Okay, so watch what's going on here. So right there, we know tangent is what? Y over x. So what would the tangent be if I was using these coordinates? 0 over 1, which is 0, right? That's why this graph here is starting down here at the origin, right? Okay. So we're going to start going through this. Right? We see this, it's going like this, it's beautiful, it's beautiful, it's beautiful. I want somebody to tell me what's going to happen when I get right here at t equals pi over 2. right here. I want everyone to look at the ordered pairs. What's the ordered pair here? 0, 1. What would this be if I wrote it as a tangent function? 1 over 0. What does that tell me? It's undefined. Okay, now what really is happening here is, if I wanted, I could graph a line at x equals pi over 2. And if I come back over here to this, if I were to zoom out and drag up here, this graph of tangent right here is getting closer and closer and closer and closer to pi over 2. It's getting closer and closer to this line right here. And this line is called a vertical asymptote. It's referred to as a vertical asymptote. So it never will equal pi over 2. It cannot hit that. Why? Because at pi over 2, it is undefined. You cannot take the tangent of pi over 2. It's undefined. So the graph continues to increase forever as it gets closer and closer and closer to pi over 2. All right? Now I want you to look over here. Then what happens once I go past pi over 2? Okay? Let's undo this and go back to our slider here. So if I go past pi over 2, look where it is now. Let me turn my pi over 2 vertical asymptote on. Look down here where it's coming from. It's way down here. Look at the values on it. Negative 17. Guess what? It jumps on the other side of pi over 2 and starts coming up from negative infinity. Okay? It literally is doing that. It's coming up from negative infinity. Because if I take 0.936 divided by this negative 0.352, I get a very small negative. When I say small, an absolute value would be a very large positive. So the graph has these asymptotes, and I want you to look what's happening here. When is this going to become undefined again? When am I going to have a 0 in the denominator again? When x equals what? 0. When does that happen next? What is this angle down here called? 3 pi over 2. Guess what? If I were to draw a vertical line at 3 pi over 2, okay, put it on, you will notice this part right here is that. See what's between those two asymptotes? That is one cycle of tangent. This is what it looks like. It literally grows, comes up, crosses over here, and then continues to go up, and then it repeats. And how far is it between pi over 2 and 3 pi over 2? Pi radians. That's the period. If I went back this way, there'd be an asymptote at negative pi over 2, and it would go back down like this. If I went beyond 2 pi, at 5 pi over 2, it would go like this. There'd be another asymptote right here, like this, and this graph would go like this again. It continues this over and over and over again. That's what the tangent graph looks like. Okay? So again, why do we have these asymptotes here? What is the purpose of those asymptotes? Why do they exist? It's the cycle, but why do we have these spots where the graph can never go? Because at those values of theta, those angles, the tangent is what? Undefined. And why? Because the denominator has a what in it? 0. You cannot divide by 0. So that's why the tangent curve has that happen to it. The tangent curve will be undefined anytime x equals 0. Okay? So let's think about this real fast. I'm going to go back to that page I had before we were kind of doing a review on. This guy right here. Let's talk about this a little bit more then. So will the sine function ever be undefined? Is the radius ever 0? No. Will the cosine ever have an undefined? No. Did we ever have asymptotes on those? No, we didn't. Okay, let's talk about this then. Tangent. We know it's undefined, right? It is undefined when x equals 0. When does that happen? At what angles of theta? So that happens at pi over 2 and 3 pi over 2. So it's got vertical asymptotes at those, and it's got vertical asymptotes at those pi over 2, 3 pi over 2. If I kept going, it would happen again. Same locations, okay? Let's talk about cosecant. What about this? Will the cosecant ever be undefined? Yes, the cosecant will be undefined. Green. Here we go. This is undefined when what? Y equals 0. When does that happen? Pi, or I could say at 0, pi, and 2 pi, right? If I think of it that way, right? So what does that mean? That means that the cosecant graph, when we look at it, it's going to have what? Vertical asymptotes on it. It's going to have vertical asymptotes on it. What about the secant? What about the secant right here? Guess what? It's going to be undefined. It's going to be undefined when what? When x equals, oh, we know when that happens. It's undefined at what values? Pi over 2 and, so guess what? It's going to have vertical asymptotes on it as well. Cotangent. Hey, guess what? The cotangent is also going to have what? Times where it is undefined. When y equals 0, that's where? 0, pi, 2 pi, right? So sine and cosine do not have asymptotes at all. All the other ones do. And the reason they do is because they have a possibility of the denominator being equal to 0. Okay? That is why. So let's real quick look at those graphs. I just want you to understand why these have asymptotes on them. All right, so you're just kind of watching right now, guys. You're along for the ride. Okay, let me find, here it is. Okay, so we've already looked at this. So right now I'm going to get rid of the circle. I don't even want it on. And I don't need that little feather part either. Let's just, whoa, undo that. And I want to get rid of the triangle. So, beautiful. There's the tangent. I'm going to do the cotangent next. And I want to compare it. Okay, what's the first thing you notice about the cotangent? It's not increasing, it is always decreasing, isn't it? The tangent function's always increasing, the cotangent's always decreasing. You can see that here, okay? Does it have the exact same asymptote? So here, the asymptote's at pi over 2 and 3 pi over 2. If I turn this off, what do I notice? The cotangent's not there. It actually passes through there. We said they should be where? 0, pi, and they are, aren't they? They are. They're doing exactly what we said they should do. But they go the opposite direction. So you can see those. Boom, asymptotes. Okay. Why is this still there? That part of the graph. I drew it, that's why. It looks so good. I couldn't believe it. Okay, here we go. Let's put on the sine function. And let's get rid of these asymptotes here, okay? So, what is the reciprocal of sine? Which of the other ones? Cosecant. Okay, let's look at the cosecant. Here we go. Okay, I want everyone to look at it. So we said there'd be an asymptote here. Let's make that actually, let's make a. We said there should be an asymptote here, which there is. And there's an asymptote here, we said. These squigglies are asymptotes, and this is an asymptote. Okay? What do you notice? Where the original sine curve was 0 is where the asymptote is for the cosecant. Okay? Because those zeros would end up being in the denominator once I flipped it over. Do you notice that they have the exact same spot here they share? So here's what's really easy to remember. If you know what the sine curve looks like, I'm just going to do this by hand real fast right here. Actually, I'll do it over here. This is what I always tell my students. If you ever see something that talks about like cosecant or a secant, if I know this is a sine curve, all right? If that's the sine and I want to do the cosecant, the first thing I do is I say, okay, this is where the cosecant is going to be what? Undefined. So you do what? You have your asymptotes here, here, and here. And then guess what you do? All you do is take this graph and do what? Flip it. Why? Because all you do for sine and cosecant is what? Flip it. So the graph goes like this instead. And then down here you flip it and it goes like this. If you understand that, that's all I care about. That you understand that it's just the reciprocal. So the graph gets flipped. Whoop, whoop. And if that's true for cosecant and sine, guess what? It's also going to be true for cosine. Now guess what? Let's look at cosine. Where's cosine equal to 0 at? Pi over 2 and 3 pi over 2. When I flip it, those are going to be in the denominator. That means that's where my what are? Asymptotes. There's going to be an asymptote here. There's going to be an asymptote here. And then guess what happens? All you do is take the graphs and do what? Flip them. So guess what this is going to look like right here? It's going to go like this. Guess what this would do? This part would go like this. Guess what this would do? This part would go like this. Let's see how close I am. You ready? Here we go. Cosecant, secant. Oh my goodness. Amazing. You see it? That's what I need. I need you to understand what they look like and why they look like it's all I care about. I am not going to ask you to graph a single cosecant, secant, cotangent by hand. Okay? You're not going to have to graph any of those by hand, but you should understand why they have asymptotes and why they have asymptotes at their locations they do. And it's because that's when they're undefined, because the denominator is equal to 0. Okay? All right. We okay with all that? Yes? Okay. That's good. All righty. Let me go ahead and it's a good day. Oh, yeah, yeah. All right. Let's go here. Let's go here. And we also have to understand the periods, by the way. Okay? So if I put a new page on here real quick, this is review. This would be a review question right now. So sine theta, the period is what? What's the period of a sine function? 2 pi. Cosine theta, period is 2 pi. Okay? Boom. Love it. Tangent theta, period is pi. Okay. Now, guess what? The reciprocals have the exact same periods of their counterpart. That means cosecant's going to have a period that sine has, which is what? 2 pi. This is going to have a period like cosine, so it's going to have a period that is 2 pi. This is going to have a period like tangent, so it's going to have a period of what? Pi. So 4 of them have 2 pi as their period, 2 of them have pi. Okay, those are cool. All right. Now, this is going to be important once we start solving equations in here later on. When we start solving equations, understanding the period will be important. Okay? And what does that period mean? It's how many times it goes through a cycle, right? We should understand that, okay, up to graphically. Okay. Let's see here. What should I... Oh, I have a good question for you. Woo! Woo! Okay, here's my angle, theta. What is this angle here referred to as? It is supplementary in this case. That's one thing you could tell me it is. There's something else. It's the reference angle. It's the reference angle. Okay? That was important for us. So if I told you, let's just say I told you that this reference angle here, let's just say that this angle x, let's just say it's equal to, oh, I don't know, how about, oh, pi over 12. Reference angle is always a positive angle, and it's always acute. If that's pi over 12, how do I find theta? Who remembers how to do this? We talked about this a ton. Thank you. Theta would be pi minus pi over 12. I know this is pi, so I'd have to go subtract pi over 12 from it. So if your terminal side was in quadrant 2, and you knew the reference angle, you subtracted from pi. What happens, though, if your terminal side is not in quadrant 2, but instead it is in quadrant number 3? Let's say, in other words, that this angle right here, we'll call this one beta. There's beta. And this is the reference angle to beta. We'll call it, oh, I don't know, how about alpha? And I tell you that alpha equals pi over 12. B, beta, would be pi plus pi over 12. So if the terminal side is in quadrant 3, you add the reference angle to pi to find your angle. What was the other option? Oh, that terminal side could be where? Quadrant number 4, right? Let's go ahead and draw one there. How about we do a paintbrush? Oh, I like that. We'll go with yellow. You're not going to let me draw like that, huh? Oh, there we go. Beautiful. There it is. Okay, so let's say that that is my angle. So my angle goes from, where's my paintbrush again? We'll go right here. So this angle right here, we're going to call that yellow one. Oh, I don't know. How about phi or phi, whatever you want to say. It doesn't matter to me. Okay? That's phi. And let's say that this angle right here is pi over 12. How would I find this one? 2 pi minus. All right. That is going to be very important in here again. Very important in here again, all right? Okay. All of this, these are things that we've been doing in here. We just got done doing graphs. This is what the stuff we were talking about before that, okay? So today, here's what I want you to do, because this, we need to review before we move on what we were doing before graphing, okay? So you're going to be working on this. I'm going to give this to you in a second. Oh, I think it's on the other screen. It is. Hello. We were doing these kind of problems before, where I would give you one of the trig ratios. I tell you something about the other ones, and I asked you to find the following ones. Remember me doing that in here with you guys? We did a lot of this. You're going to be doing some review today On this, here's reference angle. Find two positive solutions to this.
Students and staff, please pardon the interruption. This is just a reminder to our senior students who ordered graduation announcements. Those graduation announcements can be picked up today during lunch in front of the recital hall. Again, those can be picked up today at lunch in front of the recital hall. Thank you.
Okay, so here, review. I'm going to change this. I don't want this to be in degrees. I want this to be in radians. I'm going to change that in a second when you get your paper. Here, sketch. This is something you should still be able to do because we want to make sure we understand the sketch, the graph still, because that's how we're going to understand the solutions when we're solving for equations. All right, boom, boom. I want you to just sketch a tangent graph for me. Simple, simple. Nothing crazy there. Asymptotes and stuff. More review, more review. Can you write a function still for one of these? That's it. It's review. It's a review day. And that way, when we move on, this stuff will go over and you should be good to go. Okay? So I'm going to give that to you. And as I said, I want you guys to, when you get this paper, I want to change this. And I want to make it like this. I want this to be in radians instead. Okay. Oh, this over here. Onliners, it's posted. It's posted, onliners. And this is actually what I want you to be working on. I don't know why this gave you one. You just going to do it for the entire row? I guess so. This is what you're going to be working on tomorrow. Okay? And then on Wednesday, I'm going to send you a reminder. I need you guys on Wednesday to review and look over your trig identities in here that we've been working on too. Remember those? The trig identities in here we talked about, like sine is the same as 1 over cosecant, right? There was the Pythagorean identity, sine squared plus cosine squared equals 1. There were even odd identities. There were quotient identities. I need you to start reviewing those on your own. So you're going to be working on this today, tomorrow, Wednesday, and you need to review your trig identity. Oh yeah, and then if you have the bonus, you can give that to me today at some point. That's fine. You can just hand it to me at some point. I'll take it. Yeah, I got your email. I look for you. Well, I need. You have anything on this too? I said you could get partial credit if your decimal scrap's not right. And find out what you got here. Sure. Yeah, as long as you give it to me today, that's fine. This would be easier for me to do it here if you could. Is that okay? Okay. You still have your copy of this? Okay. Yeah, that would be great.
I mean, that is kind of so we're just doing the you've been late.
Oh, no.
Hey, did you know lawn Sunday? Yeah, all day. Oh, goodness. R. Right? Is it 13R? Sine is, yeah. And R can't be negative. That's the itself. But then it's 8 by cosine. If you have R, you have to do like a diagonal. Oh, that makes sense. Cosecant 13 over negative 12. Wait, why does it say sine? You tried this. So that's 5. would be. Yeah. Yeah, like 11 o'clock last night. I got done pretty fast.
It's funny.
It's okay. Time you got the quotes. The essay should be this way. What? I think so. But we have today. Do we have today? Yeah, and I think she's taking us Thursday and Friday to work on it in class. You have the tick in your system. No one. On Wednesday. It's tough. It's failing my biology class.
Hey, bud.
Wait, so if there's some, you just do. Oh, you have to.
You gotta find that, it's like,
Yeah.
because that's just. Yeah, I do that. This sketch mark. Oh.
You get like a design for all.
I just use the rat. I think you just keep them around. Like just the rat.
Yeah, you can.
Yeah.
Do you got 7 for?
Yeah, I got it.
Why? So why? And one. No, because they signed one. Yeah. So why? Yeah. Right. Yeah. Right. How do you know? So X squared plus well squared. Why would we the sign? It's cocaine because if it was the answer, that would be no. We don't know what we don't want. Oh, it's just cocaine. Yeah, so it has to be more fun. It can be because of the positive. So it has to work. Yeah, cocaine positive.
I forget.
Okay, so
Wait, for this one, did you get 1.04? 1.5.
Yeah, I should probably find it. Wait, because you just do whatever minus 5.
Yeah.
And then the other is kind of like,
Yeah. That's 1.
yeah. Because.
So
Because
minus 4.
Yeah, but we know the why. Yeah. Oh, it doesn't.
Sign.
So, it's negative and it's extra for why. Why do we think what? Why do we have this report? We did. Because. You said. I don't know what I said. I'm not quite sure.
I know it starts at -4. That's the mid one. The amplitude's 2.
Why did we do that? So all of the
Negative. Negative 2.
No, just the five.
Then you need to find Q.
And not.
It's 1/3. B is 1.
Oh, yeah.
Then you do a 2
Yeah,
pi over
no.
I think it starts at -4 or 0.
Yeah, it starts at 0 because there's no phase shift.
Yeah.
But it's not a 2 pi cycle. It says it has 1.
Yeah. So would it be 1/3?
Normally if it's 2 there, that makes it smaller, so that makes it bigger.
Wait, would it be 1/3?
It'd be bigger than 2. It'd be 2 pi. 2 pi.
Yeah.
And like the pi versus divided by 2 pi.
Yeah, I'll have to do it. Yeah,
I'm not sure.
but I'll give her like you know.
I don't know how to do it.
Divide
It's 2 pi divided by 1/3, which would be. What would 2 pi divided by 1/3? Would that just be 2 pi?
Yeah. Now I agree. So it's just the high plus five.
It might be. Yeah, I think it is. Because if it was 1/2, it would be 4.
Yeah. All right.
But if it was 1/4, it'd be 8. So yeah.
So we go
6
The
pi.
radical.
So you just go.
I just thought it would be 6.
Oh, yeah, it is.
1, 3, 5.
That's pretty cool. I'm thinking you simplify that. It doesn't. You don't have to. Yeah.
One.
The sign.
Half of 3 is 1/2.
I kind of just
1 and 1. Do you need to do
I mean, that's what it is.
Yeah. That'd be 4.
Yeah.
So we don't have to hit these.
So it starts there. Wait. Yeah, it's at a max there. So at 2 is at -2.
Wait, is it?
Starts at the middle. Yeah.
Yeah.
So it goes to a max, then back to the middle. Then to a middle.
And then back to
Not
the
square.
No.
Radical, I mean square root. I don't know how to say it. Radical, radical. Radical something over negative.
like that.
Or.
Yeah.
Why is there a table for people?
So it starts at -2, it's got an amplitude of
Reference, and your angle's like just barely over. So it would be right here.
-2.
Because on one of our pages. Not two. So.
And the other would be 1.
Yeah. One negative.
So it'd be, so it has to be the second.
Okay, so it's a 2 there. And the
Yeah.
phase shift of minus
I don't know. I feel like,
yeah,
yeah,
minus 6.
yeah, we do that.
So that'd be plus minus 6.
What?
Right. So it's minus and
I managed.
Wait, when it would start. pi over 6.
Yeah, not
And then it'd just be a 2 pi. I think.
Find
Yeah.
two pies.
no, it wouldn't be 2 pi.
Oh, wait, you wanted to go.
It'd be pi.
Just keep it in pi.
Because it's a 2. It's a 2 pi.
Oh, yeah,
That's right.
I
I
think
think
it was 2.
Yeah.
Is this a 2?
I'm finding fun of this.
That's good.
Almost like, that's the same one.
Doesn't start on maximum.
Yeah.
Oh.
So it's pi over 6 plus 1/4 pi.
What they have to do is.
What would it end at? Pi over 6 plus
Why has to be.
Oh crap, I think that's 7 pi over 6.
Gotta be.
It ended at,
Yeah,
it ended at 7 pi over 6.
Negative y. That's gotta be on top of it. How do you find it?
And in the middle would
I don't know. They don't get same thing that hot, so like
be pi over 6 plus 3 pi over 6. 4 pi over 6.
Oh. Yeah, I think so. Do you like the code sound? Like, no, I think we do it right.
And then that's all we need.
Pi. So 2 pi plus,
Because it starts at 1.
right?
Wait,
Pi plus.
wait.
It starts at pi over
Oh,
6.
Yeah, but it starts, yeah, like the y value. 1.
Yes.
And then it goes to the middle of those two, which we probably have to find out. And then it goes to here. Back to the midline.
No, because that's not how we do it. Yeah, don't figure out what we want to know what the it's it has it's definitely I'm telling you. Whatever you read, tell me what it's not a gradient. It's just a oh it's 1.3. No, I wouldn't say more about no, what do you do about dude, it's definitely 1.45.
Yeah, so what-
Signed it in May.
And don't we just have to do,
Right? Yes, I did.
What did you change?
I remember.
what the change?
Oh, the tangent.
It's definitely.
It's going to like,
So tangent is y
There's a
over
lot
x,
on
right?
your calculator. It's
Yes.
not finding
So the
things for
asymptotes
sine,
are.
How do you talk
Oh, I didn't.
Yeah,
Sorry, what did you
I
So
don't
but
see
I don't know if you can actually use that.
How?
But I just wanted to.
because if you do the thing on this,
Yeah, it's in the third and fourth.
yeah, 30.
How many
Or-
ratings
You plus 5.
I don't know, when I put it in, I got back a negative number, so
But
I
that's
just
not how many
did that
ratings.
time.
Yeah,
Okay,
Wait,
so,
convert, I don't know
yeah,
how.
the number I got back was like, I should have
Schneider, how would it convert
1.326.
rating? 35 plus 66 and 25
Like,
Yeah.
Oh,
Gradient.
I'm telling you. So. I can do that.
So for tangent, we only have to do that y.
Reference
Yeah.
the data.
yeah.
But do we have to draw more?
Yeah, just, we have to.
Yeah.
So now you're going to find the reference angle.
Yeah.
Once you have the reference angle, and
Wait,
that's going to
so
tell
since it's
you
over x,
this angle.
the,
It's also going to tell you that angle. And that's the
Yeah,
reference
that's
angle
actually-
right here.
asymptotes are,
Right. I was right.
what's it called? It's pi over 2 and 3 pi 2. Yeah.
How are you right? I just remember. I don't know how I just did it. You have to take the negative
There
sign,
you go.
the inverse sign of what we got.
There you go. 1.3.
Your answer is. I mean,
Okay, so yeah, it never hit pi over 3.
What's the absolute value sign? Yeah.
Wait, so it goes like up.
So it's,
Yeah, this one always goes up.
how does
Looks like a.
okay, so it's one, I think 3. No, 3 is definitely right.
So it goes,
You're
wait, this was, how did this
It was like it was like this.
yeah, no, it's like this.
I don't know if I'm doing.
No, it's like this.
Yeah. Yeah, that's right.
But
Oh, yeah, I forgot.
I'm all right.
It was clearly so.
Oh, yeah, that's.
Wait, what are you guys
And then right here, it went, I forget what it did.
You don't put that in. Not gonna be that. Well, neither is the first. Oh, you're the first.
It would do the same thing on the
I do like
Yeah, but it's only like half.
plus. Yeah.
See, does it start like down?
You go up. So that's not exactly what I know. It's more exact. No.
I think it's just like this.
It's not more exact.
Wait,
Does it look like that? That's not.
You can't get.
I know the middle of this.
That's not more exact. Our he's never. Like we always. Yes. Well, then I'm gonna put I.
Right, so
Easier.
Well, this, the next asymptote would actually be over here negative pi two. So we do this exact same thing here, so from here to here, it's going up. Yeah, but from here to here, it's going up, this graph will always increase. So it always increases from the left asymptote to the right asymptote. If it's the opposite, correct.
So what did I?
Oh,
Was it close?
kind of. From here, it just goes like this. And then from here, it just goes, wait. It goes like this.
Is B6. No, B is 1/3. Oh, yeah, the periods. Well, why?
Is it like it reaches it?
Yeah.
Yeah.
Wait, we gotta do this one. Find 2 positive solutions to theta. Here it is. So it's a circle. It's sine of theta equals.
This is what I did. You know, on the circle, like this thing.
Yeah.
But this is these are positives.
Mhm.
And because
So
sine was negative, right? So it had to be
What did I?
positive.
This would be one of those.
So then it had to be plus 5 and then minus 2 5. This
No, I mean, yeah.
Find 2 positive solutions to theta. Sine.
Then it goes.
I still don't.
Okay, I got a really weird.
I don't really get it.
Huh?
What's it like?
it's like it's asking for
Like points on the graph on the circle.
well, I think it's asking for like it's not it's so it's this is a referencing, right?
Oh.
We're just trying to find we're trying to find
Okay. Oh,
the end.
yeah.
And I don't know.
Okay, so they're great.
I would-
That's so you divide it by 2. So first, I'm just gonna go back. The first is good, 6 pi.
Cosine is greater than is greater than 0. So
So the middle should be 3 pi.
wait, cosine is cosine's what? X over
The middle
r.
Yes.
Yeah, cosine's x over r. Tangent's x over y.
So what's the middle?
So the 10 has to be positive.
So it'd be 1.5 per 0.
The 17 has to be negative.
Yeah.
So cotangent is negative 17 over.
So we didn't
And
label.
sine is negative 17 or whatever. Already.
It was like, or it was like right.
Oh.
How do you do that?
Yeah, just Yep. the radical 3. So 10 over.
2 pi over, no, 3 pi over pi.
No,
3 pi over 2.
Yeah, I think it's 17.
It's both.
3 pi over 2.
Is there sine?
Oh, you're right. Oh, I thought you were on this. That's why. Yeah. Yeah, you're right. You're right.
Cosine's 10 over. Yeah, sine's 17.
9 pi over 2.
Right?
Well, isn't tangent y over x? So the 10 is.
Yeah, sine's the y value. So yeah, you're right. It's 10. It's 50. That's fine.
It's kind of confusing.
That's the max.
Yes. 10 is 30. And cosecant. That's the opposite of sine. Would be radical 3 over 9.
So it starts at negative 4 pi. Yeah, it starts at negative
This next one.
Bro, we only have
How to find.
and goes back to
See, there's tangent is negative. Or
So you find it
negative
here.
But do you just put it over
Then
one?
you divide it by 2.
tangent, like tangent is.
Yeah, so divide by
Like, do you just put this
Yeah,
over
yeah.
one? Or do we have to find?
Yeah, you're supposed to divide.
Secant is greater than 0. I feel like this is where we just use like the circles.
Oh, yeah. Well, what's pi? What's
Yeah.
Oh, what would it be?
Negative radical.
No, it'd be radical. It would be 1 over radical.
Wait,
Is it 1 over 2?
There's a 1 over.
It's 3 over 2 and then 1. Right?
Oh, yeah, yeah.
Oh wait, but there's no 3 over.
Yeah, that's the.
The minimum. This is what I'm.
Oh, wait. Yeah, there's a negative radical 3 over 2. Isn't there? Like on one of the points.
So we put it over.
That's saying that.
We're putting it over 2.
Yeah, I'm pretty sure. What are the points? It's like.
Oh wait, but then.
And then it's like 1/2. And then it's radical 3 over 2. Is it negative?
I don't like it when it has.
For what?
Well, what's isn't 1, 2, 3?
Yeah. So like this one is radical 3 over 2.
Yeah.
1/2.
Yeah.
And then this one's radical 2 over 2. Radical 2 over 2. Radical 2. And this one's just 1/2 radical 2.
Yeah.
So where's the radical line?
But yeah, but we can't.
Tangent negative. Right?
No, tangent negative. So it can go.
So it's gonna be
So as-
greater. But where would secant is greater than 0? What's secant?
It's
That's
It's,
cosine. That's the opposite
yeah.
of cosine.
So it's this.
Which is x over
It's over. No, what?
no.
It's x over
Cosine,
tangent, right?
cosine is x over
Or
x over all. So it can't. So that's saying that x cannot be negative. So it's got to be up here. Got to be one of the values.
Oh, it's positive then.
So if it's got to be there,
Yeah, but
what are the values in here? That 1, 2, 3.
or is it 2, 2, 1?
It doesn't start at 0.
That's 1/2.
I think we're over.
No, that's negative 1. It's this one right here.
This is
It is negative 3 over 2.
So the period, not the negative 2. Wait, so if the period pi
I believe.
Wait a minute. Yeah.
Right? That's that value right there.
Yeah, but I don't know.
So it's saying it's that right, so that's just saying that that's.
That's pile five.
Yeah, no.
I don't know what. I don't think.
Well, I guess if you put three radical 3 over 2 over 1 over 2.
I don't think that's what you mean.
Oh, yeah, no, that's right. No, I think that's right.
Is it?
Yeah, because if you simplify it, I think it just goes to negative radical.
Oh my god.
Because the 2's cancel out and then it's negative radical 3 over 1.
Yeah, you're right. Yeah.
So yeah, that's right.
Okay, so then that means the x
So cosine would be
negative radical 3 over 2 over r, which we have to find.
which is no. Oh wait,
Oh, yeah, no.
it's just radical.
R? The radius?
Yeah.
Oh, sure. Nice.
The radius is unless this is saying that it's 1 right here, it just does say. It's,
Oh, max would be a 1, -2 plus 3.
I read that.
Okay.
That is exactly minus.
Oh, yeah,
right now,
right.
x we think is negative radical 3 over, no. Yeah, negative radical 3 over 2.
Okay, wait. I think it is negative radical. Because that's. Wait a minute. Wait a minute.
We're on this one. Is this one we use this first one?
That's an exact, yeah.
Yeah.
Number 7 is exact.
So we're saying 2 pi over negative 3. Negative radical. That would be the point.
That's negative, that's going to be negative, well, but, you know, because secant is positive,
So that's
that means cosine is positive. So you're quadrupling. Because secant is reciprocal of cosine. So it's positive in the same place. Right, right, x has to be positive.
Lowest is -5.
So this is your y box. Remember, tangent is sine over cosine. So you need a -3 in the radical numerator. So negative radical 3 over 2. That's your y box. Your x value is exactly.
So the y, so you were right, it doesn't be down here.
Okay.
So the y is negative radical 3 over 2.
-5.
And then the x is 1/2.
-2.
Oh, so it'd be that.
What are your?
Wait, so it's 1/2.
-5 or 6.
1/2.
X is 1/2.
It's not
So
negative.
cotangent is 1/2. What's 1/2 over that negative radical 3 over 2? Is that simplify or no?
You got something.
Wait a minute. 1/2 over.
For cotangent.
This point.
Well, it would be 1 over radical 3 or negative radical 3.
Would it? Yeah, I think that might be. Yeah, it'd just be 1.
Are you?
Oh, yeah. Because tangent's negative radical 3. So it's 1 over negative.
Oh, thank you.
So then sine would be.
Sine, we have to find all of it. So basically, you just have to do 1/2.
Look at my graph.
I got like 0.7.
Yeah, I think it makes it like 1/4.
Yeah, I got 11 pi.
Yeah, 0.75.
5 pi over 12.
No, just point, or not 0.2.
I think you're good.
So you got when you did 1/2 squared.
Oh, 0.5 squared
So I got 0.25.
plus.
2 pi over 12.
Where is the radical 3 over 2 squared?
Radical 3.
I got 1.75 when I added the. Oh wait, and then I can.
Wait,
That's what I got. Are you in? Are you in radians or degrees?
Is it cosine?
Maybe try radians. I don't know.
0.75.
Look.
Well, I got 1.
You're putting in the wrong spot.
Right, or 0.5 squared.
0.5. It's not 0.5.
Why did it go down
there?
Yeah.
Oh, yeah, 0.5
So my
squared.
graph literally just.
I got 1. Wait, because you can't put 3 over 2 together.
Oh, I have to do radical to 3, and then,
so, which is 0.75.
okay.
Then it's 0.75 and 0.25, which is 1. So it is just the circle. Wait,
So,
because so we have what's the square root of 1 is 1. So yeah.
yeah,
So the radius is 1. Because we're using the circle line.
One.
So okay, so cosine.
Oh
Yeah.
my.
so wait, so then we can
So
just do,
cosine is 1/2 over 1.
Okay. What's the midline? 2 negative.
We don't even have to put it.
yeah, no, I think we just
It's
need
just
to,
1.
what, wait a minute.
It's literally just 1.
Okay.
The cosine is the x value, so it's 1/2. Sine is the y value, so it's negative radical 3 over 2. Cosecant is 3 opposite little side, right? So it's 2 over radical 3. 2 over negative radical.
Man, it doesn't cross it.
Secant is opposite cosine,
That's
so
where it
2.
doesn't go out.
And then theta equals, what do you do for that?
Where is it? It's on the graph, right?
Yeah.
It's which
It's in
one?
quadrant 4.
So it doesn't.
It's right here.
Yeah, so do you have to do like a reference?
So it's 2 pi minus that.
2 pi minus that, it's that coordinate.
That coordinate.
Right.
How's that?
Alright. Wait, why couldn't we just do? Wait, 1 is, 1 is, wouldn't 1 be x?
1?
Yeah.
No,
The period is 55. How many of these do you recall?
I don't think so.
No, it's not. Wait, what'd you get for secant?
Too bad.
Secant, I got 2.
Wait, what? It only goes up to 5, right? Yeah. You want to keep doing more than you do.
I'm not really sure.
Oh, wait, actually, yeah.
What's this?
Do we have to draw that? Actually, what's theta? What angle is that? That's a familiar. Where does that happen?
Oh, what?
What's theta?
Then,
Yeah.
this cosine is just,
You know, I'm looking up now, this way.
because it's just,
Actually, I'm doing.
alright, so it's just.
Yep, it's all around. Like that.
Wait, so this is.
So wait, this has to be a, this has to be a,
Where's your asset? We're on control. You didn't
Alright,
start
so
it.
isn't it one,
Okay, that's.
it's the 3, 2, 1?
Dude, it's literally, I'll do that. Yeah.
So that one's radical 3 over 1, and then that's 1. So that's 1/2. That's circle radical 3, that's circle radical 3, that's circle
Yeah,
1/2.
we did it. We didn't like that.
That's circle 1/2.
So I think it starts here.
So
The
this
x
is what
value
I-
1/2, yeah, so this one right here.
Yeah, yeah.
So where's the other one? So
That's just the draw.
this is pi over.
Yes, you draw it.
Oh, that's what it is. That's,
Pi over 6.
oh, this is
No,
a-
pi over 3, that's 2 pi over
Start
3.
with my.
it's 5 pi over,
2 pi over 3, that,
I think this is 5 pi over.
yeah, that's 4 pi over. That's 4 pi over 3.
And it just.
Is it 5 pi over 3? And then the 7 pi over 4. Is it?
Yeah, yeah, I said it, yeah, 5
Yeah,
pi
so
over.
5 pi. Oh, yeah.
So you know that's.
So that's 5 pi.
Yeah.
Yeah.
I don't know. You don't have. the-
Okay, okay. But a sine kept
They
saying,
don't
which
even-
we
Oh my God.
Do,
yeah, negative cosine.
okay, so
Yeah, with
the y value is at -1. Or no, k value. K equals -1. A equals 2.
yeah.
Amplitude is 2.
But cosine is
The,
which means the y is.
B value is 1/2 pi.
And I get my ball.
So the period, or no, the period is 1/2 pi. So the B value
Yes.
is 4. So B equals 4.
So it's the y and
4 pi or just
so
B is
So
4.
why is negative?
Okay.
Because the period 1 half pi.
Oh, yeah.
So if it's 2 pi, and then the H value is 0. So it's just y.
Radical 2. I said. Same thing.
4 minus 4.
The raised the radical of 390 already given to us. Basically, raised to the y. Negative. So this one.
Oh, 4x.
Yeah, you don't have to like do that since there's no page. But yeah, other than
Should we check on the decimals?
Then you give it.
yeah, we
Is it sign one?
do that real quick.
So that's negative. Actually, and then first one is the opposite. Negative. They didn't even give us. This is like 2, 4x. Right.
So I know
The only one that's positive is the cosine triangle.
Let's say I had, let's say I had negative 5 over 1. Okay,
So that means 1
is the axis. So that's
I have C
some. That's just the two.
What's the same?
Actually, it's like you saw here.
It's the same.
I need to find myself.
so
So based on y. So it's in part of the word.
So I'm going to sign a theta would be.
Oh, and then negative this negative.
Negative or negative 2.
Yeah.
This is where,
What do you have all these?
yeah,
These are all right.
listen, this is the reference.
Why? I think it does. No. Negative right.
You know,
The sign rate X. So the rate is
what?
Oh, well, 3 squared. No, the square root of 3. So 3 opposite of 1. R squared.
What?
Yeah.
2, because now we're on the right time, now we're just talking about this would have not be negative, now it's the reference, it's positive 2. So what?
It's on the 2.
And
Okay?
Yeah, because we went to
The positive gives you the reference.
No, it's not.
So if you want to find a reference, you would have to first line like positive value.
That's 2. That's 2. That's it. But it is on the.
If, here we go. If sine theta is negative 0.973, then the reference angle of theta, okay, the sine, the sine of the reference angle of theta is 0.97.
No, you're. No,
You have to find the reference angle using and then you just do that. Okay? Yep.
Yeah, that's right.
so is that am I not even?
I don't know. I think he did it. So
I'll just slide it.
no,
How do you get that? You get the negative rate. What did you do? You take the negative one and you want to.